Okay, so when we have the problem where everything is already factored for us, that kind of makes things a little easier. It takes away that step of having to do a little extra work to figure out the zeros. Okay, so if this upsets you, you can always just write this as that. Because when you think about testing the numbers here, you are going to have to use the x minus 3 factor twice on the table. When I make my table of test numbers, I'll need x plus 2, x minus 3, x minus 3, and then my answer. Okay. You can make a column for x minus 3 all squared, and that will work as well. Either way. So when x minus 2 equals 0, negative 2 is the magic number. When x minus 3 equals 0, x equals 3 is the magic number. So number line wise, negative 2 and positive 3. So maybe I'll pick, my favorite number, negative 10. Just, something super negative, something lower than my lowest negative. Usually negative 10 will take care of that. So a negative 10 is kind of a good, and then if I can pick 0, I figure out where it'll go. 0 is between the negative 2 and 3, and then something way bigger than 3. I'm not going to evaluate these all the way out. I'm just thinking about whether the answer is going to be positive or negative. So I could do like negative 50 and positive 50 if I wanted for the two extremes. So the negative x plus 2, that's negative when x is negative 10. It'll become positive for 0, and so it'll be positive when you put in a 10. Yes, sir.
Is the bottom number always going to be positive?
No, we've had a lot that come out that way. That doesn't always, if x gets big enough, is everything going to be positive? No, not if like that numerator, if we had something where our factor was like 2 minus x, or we had a negative x, that might flip it around. Okay, but you're right in that every problem we've done, our x's have been positive in our expression, and so yeah, when we put in super big numbers, eventually the whole thing gets positive. Okay. So negative here, still negative, finally gets positive. Negative here, finally gets positive. So yeah, that's a little different. Well, no, it's not different. That makes sense. Whatever we did on this column should have been the exact same. And then, so a negative result, because remember, we're thinking about multiplying these together. A negative times a negative would be a positive times another negative. You end at negative. One positive, two negatives make a positive. That makes a big positive. That makes a big positive. It's kind of like the double root thing, and how a double root we would have behavior on either side that would be the same. I don't know if you remember that. That's what happens here when we have this x minus 3 quantity squared. We get the same behavior on either side of the 3. Okay, questions on how I came up with any piece of this? Kind of go down the list. I found the special x's. I put the special x's on the number line, so I organized my number line. I picked my test numbers, so a number in each region, and I figure out what each factor will be like. I said I think it's easy to go down. And then what will be the result when I go across, and I think about multiplying all of those. It's really technically multiplying and dividing, but the rules are the same. So we can just think multiplying. once we're all done with all this work, it's all for nothing if we don't answer correctly. So greater than 0 means I'm going for positive sections, and I should include the -2 because it comes from the numerator, not the 3. We never include the denominator stuff. So how about -2 to 3, and then 3 to infinity. Okay. Never include the number from the denominator. You always put a curve on it. If it's like this where I had 2 pluses, we still have to kind of skip it and go -2 to 3 and then 3 to infinity. We can't just do -2 to infinity. This was a little bit of a different problem with the squared. That's one like curveball you might run into. So that's problem 1. Questions? So yeah, this maybe threw you off a little bit because you had, wait, like negative plus you usually expect that to end up this alternating. And that does alternate quite frequently. So you can kind of use that to check yourself, but this, like I said, exception for that was the squared. All right, so on number 2, when you factor the denominator, the numbers that go on the number line are -3 and 1 and 7. You're going to test 4 sections of the number line. So we're going to have the x minus 1, the x minus 7, the x plus 3, my things I'm going to pick for x. So how about a big old -10 down here, and then that's where my 0 can go, and then something in there like a 5, and then how about a 10? Don't put the 0 mark on your number line unless the 0 number is one of the roots out of your rational function. So just mark the roots on there and then pick something, under this number. Find, like I said, 0 is a great pick if you can pick it. So between -3 and 1, that's where the 0 would work for me. A 5 works for me in here. Something like a 10 works for me up there. Negative. X minus 1 is going to be negative until your x is bigger than 1. So a -10 will make that negative, a 0 will make that negative, but once we get an x bigger than 1, a 5 and a 10 is positive. Negative, still negative, finally gets positive. Negative, and then this one goes positive faster. So this is negative plus, which is negative plus. So my answer are my negative sections. Less than 0 means I want my negatives. So -infinity to -3 and 1 to 7. Everybody's curved because there's no equal sign. So everybody gets a curve. Those are the easiest ones because you don't have to think as hard about what to write. You're just like, okay, curves for everybody. -infinity to -3, 1 to 7. And like Diego said, you might be noticing, you're like, there's definitely patterns to these. And some of the patterns are happening because we're kind of doing a lot of the same kind of problem. Okay, I'm not going to try to like throw extra stuff in there to trick you. We'll talk about all kinds of different tricky things. But one of the reasons that we're kind of seeing this happen every time, where the final result is we're finally ending positive is because once x gets big enough, everybody's positive because x is a positive variable in each of these cases.